Howdy! Well, that's the way we say hello in Canada. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, this scintillating place that you get to see is actually CNTAR on the shores of Lake Ontario, Toronto, Canada. It is here that when you go up above 116 stories, you go to a revolving restaurant 360 which serves you fine dine overlooking the whole city. I'm sure you're going to have a very nice time here, but do remember, all the people of Canada that you get to meet, say to them howdy. In this note, children, I'm going to start off this lecture of trigonometrical identities, where today we are going to look up a trigonometrical identity which requires to be proved, which is in the syllabus of class 10, and we're going to do it by a method which is hard and also simple. So as such, you will be taught how you can get to easy methods of solving trigonometrical identities using certain very simple techniques. So let's get started and let's look up the sum first by the hard method. And before I jump on to teaching you people the hard method, I'd like you people to pause the lecture and quickly give it a try, right? So let's look up the sum now. Now here, children, we have tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1, which is further equal to 1 plus sine theta upon cos theta, right? So take your time and give the sum a try before looking up the solution. So at the moment, we're going to look up the longer way, right, which can probably pose out to be a little bit of problem. As such, I can say that this is the harder way to do the sum. Now, children, here when we do this, then I'm sure you remember one trigonometrical identity which we're going to use here. That is, if you talk about tan theta, we can write it to be sine theta divided by cos theta, right? For that matter, there is a trigonometrical identity which relates sine theta and cos theta. That is, if you talk about sine square theta plus cos square theta, then that's equal to 1. Further, if you talk about sec theta has its inverse to be cos theta. As such, you can write it to be cos theta. Now, why are we using this? Because here what we can do is, if we convert the trigonometrical ratios that we have in terms of sine and cos, we will find that that will become pretty simple. So now we go ahead with the side which is more manipulative, or in other words, which is a little more to do with, so that we can come to the simpler side, right? So we go ahead with the left hand side and try to match it with the simpler right hand side. Now in the left hand side, children, you get to see that you have tan theta, which, like I just discussed, can be written to be sine theta upon cos theta, right? And to that is to be added 1 upon cos theta, which is the value of sec theta, and to that is added minus 1, and all of that is divided by tan theta, which can again be written as sine theta upon cos theta, right? And further to it is added minus sec theta, which can be written as minus 1 upon cos theta, right? And to that, children, is added 1. Now, as you see fractions, so our next task is to take an LCM in the numerator as well as in the denominator. In the numerator, guys, we get to see that the whole LCM can be taken to be cos theta, as the only denominator that we have is cos theta, right? And now for the first fraction, we will have sine theta to be the numerator. In the second fraction, we can take 1, because cos theta will divide cos theta by just 1, and multiplying with 1, which is there in the numerator, you will get to 1, and minus times here. Now we will bring in cos theta. Now in the denominator, again we take an LCM where we get the same cos theta to be the LCM. Now the numerator of the first fraction comes out to be sine theta. For the next, it is going to be minus 1, and then the next is going to be plus cos theta, right? So next, now, children, we get to see that 1 cos theta is there in the numerator and there's another cos theta in the denominator. So both of these cos thetas are going to get cancelled, right? As such, now we can write this as sine theta plus 1 minus cos theta, right? And which is divided by cos theta right? And now what we do is we can now write a division sign, and then we can write the term which is under the whole denominator, that is sine theta, right? And minus 1 plus cos theta, and it is divided by cos theta. Now in the next step, what we're going to do is we will convert this division sign to multiplication sign. As such, now we will have sine theta plus 1 minus cos theta, and in the denominator we have cos theta, and further now we can write this by converting the division sign to multiplication sign, and then we reciprocate the fraction which comes after it. As such, we have cos theta, which now divides sine theta, right? And here we are going to make a minor manipulation, that is, we will take a minus sign common outside, and then we can write it to be minus times or 1 minus cos theta, right? Why? In times to come, I'm going to tell you. Now next, children, what we get to see is cos theta will get cancelled from the numerator and from the denominator, and then what we can do is we can now write this to be sine theta, to which is added 1 minus cos theta, right? And as such, we will put this second and the first in different parentheses or in simple brackets. Now in the denominator, guys, we have sine theta, which can be kept in parentheses, and then we write a minus sign, and we have 1 minus cos theta, right, as the binomial written in the simple bracket. Now here you can see that we have something like a plus b, and in the denominator we have the same, that is a minus b, right? And as this is a plus b upon a minus b, you know how we solve trigonometrical identities in certain cases by simplifying them such that they are multiplied in the numerator and in the denominator by the conjugates of either the numerator or the denominator. Here in this case, what we will do is we will multiply by the conjugate of the denominator. Now quickly, I'll remind you people what a conjugate is. So if you talk about a plus b, then the conjugate of this is a minus b, and similarly if you have a minus b, then the conjugate of this is a plus b. So as here in the denominator we have sine theta minus times or 1 minus cos theta, we will be multiplying the numerator and the denominator by the conjugates of the denominator, like I told you earlier now. So it is going to become sine theta plus 1 minus cos theta, right? And in the denominator now you have sine theta plus 1 minus cos theta, right? Further now, guys, we get to say in the numerator we have the square of the term in the numerator. As such, we can now write this as sine theta plus 1 minus cos theta, which can be kept in a horizontal bracket, and then we can write the square of it, as the other term to which it is multiplied is exactly the same. Now in the denominator, guys, we are going to get something like a plus b times of a minus b, and since we know that whenever we have a plus b which gets multiplied with a minus b, it becomes equal to a square minus b square, which is what you learned in algebraic identities. So this is what we're going to do here. As such, now we will have sine theta whole square, that is a square, minus we have 1 minus cos theta whole square, which is something like b square. And further now we simplify this. As such, now in the next step we can write this to be a plus b whole square. And I'm sure you people know this, that if we talk about a plus b whole square, we get it to be a square plus b square plus 2ab. So we're going to use this formula, and now we get to a square, that is sine square theta, plus we have 1 minus cos theta whole square, right? And then we have the 2ab term, that is 2 times of sine theta, which will get multiplied with 1 minus cos theta, right? Now children, in the denominator what we next have is we have a square minus b square, remember? So as such, we have now sine square theta and minus times of, we now have here the square of 1 minus cos theta, which will become a square, that is 1 plus b square, that is minus cos theta whole square, that is plus cos square theta, and minus 2 times of 1 times of cos theta, that is minus 2 cos theta, right? Now in the next step, guys, what we're going to do is we will be expanding the square of 1 minus cos theta in the numerator. So we have sine square theta plus 1 plus cos square theta minus 2 cos theta, right? And to that is added 2 sine theta, and further multiplying it inside, we have minus 2 sine theta cos theta, right? And now children, in the denominator what we have is we have sine square theta minus 1 minus cos square theta and plus 2 cos theta, right? So further guys, next what we do is we can now write the numerator, which has sine square theta plus cos square theta, which we already discussed, gives us 1, right? Remember, we discussed this formula in the beginning, that is, whenever we have sine square theta plus cos square theta, we can replace it to be 1. So here also we will do the same, that is, here you get to see that we have sine square theta plus cos square theta, we will replace it to be 1, and since we already have a 1, 1 plus 1 is going to become equal to 2, and from that is subtracted minus 2 cos theta, right? And to that is added 2 sine theta, and further you have minus 2 sine theta cos theta. Now children, let's quickly put our attention to what we have in the denominator. In the denominator we have sine square theta minus 1, right? Now we will quickly look up one formula, that is, if you talk about sine square theta plus cos square theta, we have already discussed that it becomes equal to 1. So further, if say we talk about sine square theta minus 1, what is going to become? It will become equal to cos square theta but with a minus sign, as cos square theta is to be taken to the other side. So this is the value that we are going to replace here. As such, in place of sine square theta minus 1, we will have minus cos square theta in the denominator. So we have minus cos square theta, and to that is added minus cos square theta and plus 2 cos theta. Now children, here if you talk about the numerator, in the numerator, in the first pair of terms we can take 2 to be common outside, and then inside we have 1 minus cos theta, and then if you talk about the next pair, you have 2 sine theta which can be taken common outside, and then inside we have 1 minus cos theta, right? Now children, let's talk about the denominator. In the denominator you find that you have minus 2 cos square theta, to which is added 2 cos theta, right? In the numerator we can very easily factorize, as we can take from the binomial 2 to be common outside all through, right? And except that we can also take 1 minus cos theta common, and then inside we will be left out with just 1 and then plus sine theta, right? You can obviously do it this way, that you can just take 1 minus cos theta outside, and then inside you'll be left out with 2 plus 2 sine theta, which can further be written as 2 taken common outside, right? 1 plus sine theta inside. Now let's talk about what we have in the denominator. In the denominator guys, here we can take 2 cos theta to be common outside. So when we take 2 cos theta common outside, now we will be left out with minus cos theta, right, and plus 1. So obviously minus 1 plus cos theta or 1 minus cos theta are one and the same. That is, if you write a minus b, you can even write it to be minus b plus a. As such, here we will get to see that we have minus cos theta plus 1 and 1 minus cos theta, which will get cancelled. Obviously 2 is also going to get cancelled. As such, we will just be left out with 1 plus sine theta, which divides cos theta, right? And let's quickly check what we have on the right hand side. Right, on the right hand side also we have 1 plus sine theta upon cos theta, and therefore we can say that this is equal to right hand side, and thus the sum stands proved, right? So guys, now I'll just quickly discuss this once more, so that if you have any doubt, all of that gets removed. In the question children, we've been given here that we have tan theta plus sec theta minus 1 divided by tan theta minus sec theta plus 1, which is equal to 1 plus sine theta upon cos theta, which has to be proved. So here we know this, that as we can convert tan theta, sec theta all in terms of sine and cos, and then we will be able to get to the right hand side where the terms are also in terms of sine and cos. We convert tan theta to be sine theta upon cos theta. We write sec theta to be 1 upon cos theta, and we also in times to come are going to use the trigonometrical identity, which is sine square theta plus cos square theta is equal to 1. So here first what we do is convert every trigonometrical ratio in terms of sine and cos, that is tan theta to sine theta upon cos theta plus sec theta to be 1 upon cos theta minus 1, and then in the denominator we have tan theta, which becomes equal to sine theta upon cos theta minus sec theta, which is minus 1 upon cos theta plus 1. Now further here what you do is when you take an LCM, you will have the LCM to be cos theta, and then in the numerator you have sine theta plus 1 minus cos theta, right? And similarly in the denominator again the LCM is going to be cos theta, and then you will have in the numerator sine theta minus 1 plus cos theta. Now here, as there is one fraction which divides the other fraction because of this whole denominator, in place of this confusing whole denominator we can write a division sign, and when we write this division sign, in the next step we can convert it to multiplication sign, and then the fraction which is on the right hand side will be reciprocated. As such, the denominator will come to the numerator and the numerator will come to the denominator. In the next step, cos theta gets cancelled, and then you have this sine theta plus 1 minus cos theta as sine theta written in a single bracket and 1 minus cos theta written in the second bracket. Now if you talk about what we have in the denominator, what we can do here is we can take minus sign common outside from the next two terms. As such, we will have sine theta minus times of 1 minus cos theta. Now as you can see, you have something like a plus b, right, where a is sine theta and b is 1 minus cos theta, and in the denominator you have a minus b, that is sine theta again being a and 1 minus cos theta being b, right? This is to be now multiplied for simplification with the conjugates of the denominator. Now what is conjugate? If suppose you talk about a plus b, then its conjugate will be a minus b, and if you have a minus b, then its conjugate is going to be a plus b. As such, here we multiply with the conjugates of the denominator, that is sine theta. In place of minus, now you have plus, and then again that same b, that is 1 minus cos theta. So here next what we do is, as in the numerator we have a plus b, which is getting multiplied with a plus b, so as such it will become a plus b whole square, where this horizontal line is the horizontal bracket. And in the denominator, as we have something like a minus b times of a plus b, so it will become a square minus b square by algebraic identities that you've learned in class 9. Now further applying this, we now have in the numerator a plus b whole square, which can be written as a square plus b square plus 2ab, and if you talk about the denominator, we have something like a square minus b square, so as such sine square theta and minus times of 1 minus cos theta whole square, which is 1 plus cos square theta minus 2 cos theta. Now further here what we do is we now multiply here these terms, right, with minus sign in the next step to get to sine square theta minus 1 minus cos square theta plus 2 cos theta. In the numerator we write the expansion of 1 minus cos theta, right, whole square, that is 1 plus cos square theta minus 2 cos theta, and also multiply this 2 sine theta with the binomial, that is 1 minus cos theta, to get 2 sine theta minus 2 sine theta cos theta. Now children, as we already know that sine square theta plus cos square theta is 1, so in its place we will just put 1, and 1 plus 1 is going to become equal to 2, and then further we have 2 minus 2 cos theta, and except that we have 2 sine theta minus 2 sine theta cos theta. Now out of the first two, if we take 2 to be common outside, we have 1 minus cos theta inside, and similarly out of the next two, if we take again 2 sine theta common outside, we will have 1 minus cos theta outside. Now out of these two, we find that 2 is common all through, so as such we can take it common out, and then inside we further have 1 minus cos theta also common, so we can take it common outside, and then in the first term we are left out with 1, and in the second term we are left out with sine theta, as 2 has already been taken out. Now in the denominator, if you take 2 cos theta common outside, 2 will get cancelled with the 2 that you have in the numerator, and taking cos theta common outside, we will have minus cos theta plus 1. Now if you talk about a minus b, that is just the same as minus b plus a, and as such here 1 minus cos theta will cancel minus cos theta plus 1, and both of these getting cancelled, you're just left out with 1 plus sin theta upon cos theta. And children, this is what was required to be proved, and as such the sum stands proved, right? So are you all children clear about this? For sure, Raman? That's good. Now children, like I told you, this was the difficult and the longer method. We can do it by a simpler method if we just try and remember one thing, which now I'm going to discuss in the next page. But before I try it out and tell you people how it is to be done, I like you people to pause it and quickly give it a thought as to how you can do it in a simple way. So quickly take it as a challenge and try and do it in a lesser number of steps. So I expect you people that you people must have paused the lecture and tried to give it a try by a simpler method, right? Because before breaking, the glass of what the solution of the sum is, you should always give the sum a try, and then only what happens is your intelligence gets enhanced. Okay, now children, let's look up a simpler method. So quickly I'll try and remind you people a formula that you've learnt in trigonometrical identities in class 10. That is, if you talk about sec square theta minus tan square theta, then that becomes equal to 1. As such, here what we can do is, if you talk about sec theta minus tan theta, we can multiply it with sec theta plus tan theta. That is something like a plus b times of a minus b, to be giving us the product to be equal to 1, right? Now here children, next what we do is, if suppose we try and apply this in the numerator, we will have the left hand side getting simplified a little, as we have tan theta plus sec theta, which can be written as sec theta plus tan theta, because obviously a plus b is the same as b plus a, addition being commutative. And then for the 1 that we have, we can write it to be sec square theta minus tan square theta, right? And in the denominator, guys, we will now have tan theta, from which is subtracted sec theta, and to which is added 1, right? Now further children, next what we can do is, if you talk about the second term that we have here, again it is something like a square minus b square. So like I wrote it here, it can be written as sec theta minus tan theta times of sec theta plus tan theta, to simplify things so that we can take some terms common outside. So we have sec theta plus tan theta as the first term, and then in the next term we can write this to be sec theta minus tan theta times of sec theta plus tan theta, right? And in the denominator children, what we have is, we now have tan theta minus sec theta plus 1, right? So as you see in the numerator, we can take tan theta plus sec theta, right, common outside. So if we take this sec theta plus tan theta common outside, then inside children you will now be left out with 1 minus times of sec theta minus tan theta, right? And in the denominator you will now have here tan theta minus sec theta plus 1, right? Now further children, next what we do is, we multiply the minus sign within in the bracket. As such, we have sec theta plus tan theta outside, and inside we have 1 minus sec theta plus tan theta. That is minus sign multiplied inside, as simple as that. And now children, if we try and reorder the terms that we have in the denominator, we have 1 minus sec theta plus tan theta, right? So as such, you get to see that one term from the numerator and from the denominator can get cancelled. As such, we are just left out with sec theta plus tan theta, right? Now children, here that we have sec theta plus tan theta, we can very easily convert it in terms of sine and cos. Sec theta can be written to be 1 upon cos theta, and tan theta can be written to be sine theta divided by cos theta, right? As such, if you write the LCM is going to be cos theta, and in the numerator you have 1 plus sine theta. So if you try and match with what you require to prove, that is indeed 1 plus sine theta upon cos theta, or in other words, this is the right hand side, and therefore children, this stands to be proved, right? So I'll just quickly discuss this all over. In the question children, you've been given here that we have tan theta plus sec theta minus 1, which is divided by tan theta minus sec theta plus 1, which is further equal to 1 plus sin theta upon cos theta. Now here we are trying to do this by a simpler method, that is, we use sec square theta minus tan square theta to be equal to 1. Now if you have a problem in remember this trigonometrical identity, you can just remember it by this mnemonic that S in the order of alphabets comes first and T comes next. As such, from the one which has come first, you subtract the one which has come next in order to get the difference to be equal to 1. Remember, this doesn't make any sense. This is just a mnemonic to remember it, right? So sec square theta minus tan square theta becomes equal to 1, and thus here you have this is something like a square minus b square, and since we have a square minus b square, which can be written as a minus b times of a plus b, as such, using that, we can now write this as sec theta minus tan theta times of sec theta plus tan theta in a similar way, as we have the algebraic identity to be equal to 1. So when required, we can break this trigonometrical identity in this format. Now, if you talk about the first pair of terms, we have something like tan theta plus sec theta. We can write it as sec theta plus tan theta. Why so? Because if you talk about a plus b, addition being commutative, you can write it to be b plus a, and this is how we reverse the order of the terms. We can write it as sec theta plus tan theta, because when we talk about sec square theta minus tan square theta, we can write it to be sec theta minus tan theta times of sec theta plus tan theta. And this is the reason why we wrote it this way, so that they look to be similar, right? And now children, we have this sec square theta minus tan square theta written as sec theta minus tan theta times sec theta plus tan theta. In the first two terms, we find that we have sec theta plus tan theta common, so we take it common outside, and inside then we are left out with 1 in the first term, and in the second term we are left out with sec theta minus tan theta. Now children, if you multiply this minus sign inside, you will have it to be 1 minus sec theta plus tan theta, right? And then further, if you talk about the denominator, it can be reordered as 1 to be written to be the first term, then you have minus sec theta, then you can write plus tan theta. Obviously changing the order doesn't make a difference, because addition of numbers is associative, right? So as such, both of these terms being identical get cancelled from the numerator and from the denominator, and then you're just left out with sec theta plus tan theta, which can now be written as 1 upon cos theta, as the inverse of sec theta is cos theta. And then tan theta can be written as sin theta upon cos theta, right? Because we have these two formulae, sec theta to be the inverse of cos, so we have sec theta to be equal to 1 upon cos theta, and then if we talk about the value of tan theta, we will have it to be sin theta divided by cos theta. So we use both of these to write sec theta plus tan theta, and after that, now when we try and take an LCM, the LCM of both of these is cos theta, which is the common denominator, and in the numerator we have 1 plus sin theta. And if you try and check, this is exactly what you require to bring in the right hand side, so it matches. As such, this is what you have to do, and now you can write is equal to right hand side, and therefore proved. So did you children understand all of this? So just by making a small change, that is by writing the value of 1 to be sec square theta minus tan square theta, so many steps have been reduced, and this sum can be done in such a simpler way. So remember that this sum is a pretty important sum for your boards. Do practice it and try out sums of this type. For that matter, if you really want a detailed practice, right, I have a course ready for you people, and there you can find it at the end of this lecture. You have the description of this lecture where you can get to see 4 courses visit. So there you can visit, you will find a course on trigonometrical identities. You can click on it, right? It requires a small payment to be paid, and when you pay that, you can have this group of lectures which will make this topic really perfect. So make sure guys, you study all of this, make yourself perfect, and really get good marks in your board examinations. Bye for now, and have a nice time. Bye.